Howdy everyone, Mr. Reed here, and welcome to one more question. So today we're going to be using common factoring to factor a trinomial. So if common factoring of trinomials is what you're looking to see, well, let's get to it. Alright, so what I have up above, I'm just going to copy it right down. It's actually, usually I put my polynomial expressions in descending order. This one's not, and I'm going to leave it as not in descending order because it really doesn't matter. The process is still going to be exactly the same. So we have 20m minus 30m squared plus 15 as the trinomial we're looking to factor here. So I want to do this in the best, kind of most well accepted factoring possible, which would be taking the greatest common factor out. Now in this particular expression I have 20 and 30 and 15. Now if you wanted to, you could go through the whole GCF process for whole numbers. Generally what you're going to find is when you start working with polynomial expressions, most of the time the coefficients, or the numbers that are on the front, are relatively friendly in the grand scheme of things. So when I see 20, 30, and 15, I might think 10 first because I see the 20 and 30. That doesn't mesh with the 15, so maybe I think 15. Well, that doesn't go with the 20. Well, we're going to have to work our way down then. 10 does not work. I think I already said the 10. 5. So 5 is next, goes into 20, goes into 30, goes into 15. Just kind of play around a little bit. If that's not something that works for you, you can write the factor list of all three of them and look to see what's the largest shared factor. Or you can do a prime factorization of all of them and look for the greatest common factor that way. I think I'm going to do this one by feel is what I'm going to say, and so 5 is what the number that I'm going to settle on there. And we can double check that once we factor out the 5, because the numbers that are left, if they still share a common factor, then we missed something. But until we get to that point, we'll just say 5 it is. Now I see m and m squared and I'm like, oh, m is going to be a common factor. But the idea with common factors of trinomials, or any polynomial that's bigger than a binomial, is we're not just looking for shared things between two, we're looking for shared between everything. So in this particular circumstance, the 5 does go into all three terms, the m does not, because there is no m that's present in my third term, which is just the 15. So there's no common m, I can just pull out a 5. What am I left with? Well, 20 divided by 5 is 4, and then no m change because I'm not factoring an m out. 30 divided by 5 is 6. M squared divided by, no m's there, is still m squared. And last, 15 divided by 5 is 3. And then as I said, if I wasn't sure if 5 was actually the GCF, I could take a look at what I have left and say, oh, but is there a number that will divide into 4, 6, and 3 at the same time? And that might be a little easier for you to say no to. So we could look at the factors and say, well, for 4, it's going to be 1, 2, or 4. 6 is 1, 2, 3, or 6. And then 3 is just 1 and 3. So right away, the 4 and the 3 are going to be a bit of a problem because the only shared factor that they have between them is going to be 1, which means we can't pull anything all that interesting out. All right, so basically the way that it works with polynomials is you just look for something that is the common factor for everything that's involved. So best thing you can do for yourself is get a lot of practice with this, because no matter what kind of factoring you're doing, always look for a common factor first. It will make your expression look simpler afterwards and save you a whole lot of headache down the road. All right, folks, if that one was helpful, like, subscribe, and as always, take care.